So, welcome to Solutions with Nimabelli YouTube channel. In this video, we are going to study maxima and minima concept. First, in order to find the maxima and minima of the given equations, there are three steps. First step, we need to find the fx and fy, means partial differentiation of the given equations with respect to x and partial differentiation of the given equations with respect to y. After finding this, we make f of x is equals to 0 and f of y is equals to 0. When we make f of x is equals to 0 and the partial differentiation of x equal to 0 and y equal to 0 ಮಾಡಿದಾಗ ನಮಗೆ ಏನು ಬರುತ್ತೆ ಸ್ಟೇಷನರಿ ಪಾಯಿಂಟ್ ಸಿಗುತ್ತೆ equal to 0 ಮಾಡಿದಾಗ. Next, after getting the stationary points, we need to find a, b, c. A is equals to partial differentiations of andre here double partial differentiation means second order partial derivations will be taken place. Partial differentiations of f of x with respect to x and partial differentiation of f of x with respect to y, partial differentiation of fy with respect to y. After getting the abc, in the step 3 we need to make the table. We need to find a, b, c and ac minus b square. If ac minus b square is greater than 0 and a is less than 0, then it is called as a maximum. AC minus b square is greater than 0 and a is greater than 0, then it's called minimum. AC minus b square is less than 0, then it is called saddle point. Let's consider the first questions. That is f of x comma y is equals to x cube plus y cube minus 3x plus minus 12y plus 20. Partial differentiate this with respect to x. Okay, f of x is equals to, that is f of x is equals to, your partial differentiation of this with respect to x means 3x square. Is there is no x, then it's become 0. Here also is there x, then differentiation of x with respect to x is minus 3. Then there is no x, it's become 0. There is no x, it's become 0. We get f of x, and f of y is equals to partial differentiation of this with respect to y means it's become 0. This partial differentiation of this with respect to y means 3y square minus partial differentiation of this is become 0. Then because there is no y, then partial differentiation of this means minus 12 we get. After getting the f of x and f of y, we need to find the stationary point. How to find the stationary point? By equating f of x is equals to 0 and f of y is equals to 0. Then it become 3x square minus 3, f of x is 0 and 3y square minus 12 and f of y is also 0. Then 3x square equals to, take minus 3 to right hand side, it will become plus 3. X square is equals to 3 by 3 and x 3 get cancelled, we get 1. X is equals to root 1. Then here also 3y square minus 12 equals to 0. Divide whole thing divided by 3. Then we get y square minus 4. Y square minus 4 equals to 0. Then y square is equals to 4. Y equals to root 4. Then y is equals to, can I write this as 2? Okay, here x is equals to root 1 and y is equals to plus. It can be written as x is equals to plus or minus 1 and y can be written as plus or minus 2. Okay, it can be written as plus or minus 2. And then what are the saddle points we get? 1, 2, x is 1 and y is 2, and x can be 1 and y can be minus 2, and x can be minus 1, it may be minus 1, it can be 2, then minus 1 comma minus 2. These are called as an stationary point. After getting the stationary points, what we need to find? We need to find a, b, c. A is equals to partial differentiation of f of x with respect to x. That's become, let's consider the x, f of x is equals to 3x square minus 3. Partial differentiate this with respect to x, then f of x is equals to, we get 6x, and b is equals to partial differentiation of x with respect to y, that is f of x equals 3x square minus 3 is the fx. We differentiate x with respect to y, it's become 0. There is, because there is no y, here it becomes 0 because there is no y. Then consider c, that is c is equals to f, then c is equals to f y y let's consider fy. Fy is equals to 3y square minus 12, and fyy is equals to differentiation of this become 6y minus, there is no y, it's become 0, we get 6y. Okay, after getting a, b, c, we make one table. Consider the one table. Okay, in this so a, b, c, then ac minus b square. What is a is what we get? A is equals to 6x, b is equals to 0, and c is equals to 6y. This is the table we need to remember. So x, first one value going to represent x as we know, then is going to represent the y. A is equals to 6x means 6 ones are 6, which is greater than 0 now. Okay, then b is equals to 0 means it should be 0. C is equals to 6y, 6y value is 2, 6 2s are 12. Then AC minus A is 6 into C is 12. 6 12s are, we get A into C, and AC A into C minus B square value is remaining is 12 6 are 12 6 are 72, which is also greater than 0. Here after getting all this value in this, A is greater than 0 and AC minus B square is also greater than 0. If both are greater than 0, then it is minimum point. Okay, then apply in the place of x you need to apply 1, and in place of y we need to apply minus 2. 6 into 1 we get 6, which is greater than 0, and b is equals to 0, here also 0. Here c is, we get minus 12 because y is minus 2, hence we get minus 12. After that ac minus b square is 0, a is 6 and b is minus 12, then we get minus 72, which is less than 0. If AC minus B square is less than 0, then it is called saddle point. Saddle point. Now, in this, for this column, we need to apply minus 1 in the place of x and 2 in the place of y. We get minus 6, which is less than 0, and it becomes 0. It is 12. Here we get minus 72. AC means AC minus B square, we get minus 72, which is also less than 0, and since I consider this as saddle point. In the place of x we apply minus 1, in the place of 5 we apply minus 2, we get 6 of 2 means minus 6, which is also less than 0. Okay, then b is equals to 0, c is equals to 6y, we get minus 12. Minus into minus plus 6 12s are 72. 72 is greater than 0. Okay, 72 is greater than 0. In this case, a is less than 0 and ac minus b square is greater than 0, then it is called maximum point. So we get minimum, therefore we get minimum at 1, 2 and maximum at minus 1, minus 2. Apply that both in the given equation, that is f of x, y is equals to x cube plus y cube minus 3x minus 12y plus 20. Then it is f of 1, 2 is equals to, in the place of x apply 1 because we are going to represent minimum point, and that is 1 plus 2 cube means 8 minus 3 into 1 means 3 ones are 3 minus 12 twos are having 24 plus 20. We get, finally we get the answer, this as 2 at the point of maximum point, that is minus 1, minus 2 is equals to minus 1 minus 8 plus 3 plus 24 plus 20, we get 38. This is maximum value and this is minimum value. Therefore maximum value is 38 and minimum value is 2. So consider another one example, that is f of x comma y is equals to x cube plus 3xy square minus 15x square minus 15y square plus 72x. First we need to find fx and the partial derivation of given equation with respect to x. The partial derivative of x cube with respect to x is 3x square plus, here there is a presence of x terms, then it can be written as 3y square minus 30x, here there is no x terms and this becomes 0, plus here there is a x term, differentiation of x with respect to x is 1, the remaining is 72, and differentiate given expressions with respect to y, that is fy is equals to, this is differentiation of, here there is no x terms, it's become 0, there is a presence of x terms, then it's become 6xy minus, here there is no x term, y term, here there is a presence of y term, then it becomes 30y, its remaining term is 0. We get f of x is equal to 3x square plus 3y square minus 30x plus 70. Consider this as equation 1 and this as equation 2. From how to get the stationary points? By converting f of x is equals to 0 and f of y equals to 0. F of x means 3x square plus 3y square minus 30x plus 72 equals to 0, and 6xy minus 30y equals to 0. Divide this with respect to 6, then we get xy minus 5y equals to 0. Take y common, then we get x minus 5 equals to 0. Then y is equals to 0 and x minus 5 equals to 0. We get x is equals to plus 5. We get y is equals to 0 and x is equals to 5. Apply y is equals to 0. In order to get the stationary points, we need to apply the y is equals to 0 to once to the equation 1 and x is equals to 5 once to the equation 1. First apply y is equals to 0 to equation 1. We get 3x square plus 3y is 0 square minus 30x plus 72 equals to 0. We get 3x square minus 30x plus 72 equals to 0. Divide whole thing by 3. We get x square minus 30x plus minus 10x plus 24 equals to 0. Divide all these things, because all are divisible by 3, hence I divide all those things, then get x square minus 10x plus 24 is equals to 0. This is when I factorize this, I get x square minus 6x minus 4x plus 24 equals to 0. Take x common, what I get, x minus 4 common ತೆಗೆದ್ರೆ ನಿಮಗೆ x minus 6 equals to 0. We get x minus 6 and x minus 4 equals to 0. We get two values of x, that is x is equals to 6 and x is equals to 4. But stationary points should consisting of both x and y. In here x is 6 and y is 0. We apply y is 0, so take y, and another one is 4 comma 0. These are two stationary points. After applying the y, now apply x is equals to 5 in equations 1. That become 3 of 5 whole square. X in the place of x we place 5. 3y square minus 30 of 5 plus 72 equals to 0. When we solve this, we get 3y square minus 3 equals to 0, and we get y is equals to plus or minus 1. Okay, this simple thing when we apply this thing, and the total stationary points of this x is equals to 5 are, x will be the same because 5 comma 1 and 5 comma minus 1. Y may be plus 1 or minus 1, but x will be the same, are the two stationary points. Then points, okay, what are the four stationary points? From when we applied y is equals to 0, we get two stationary points, 6 comma 0 and 4 comma 0. When we apply x is equals to 5, we get another two stationary points, that is 5 comma 1 and 5 comma minus 1. Then after getting those two, we need to find a, b and c. A is equals to fx. X means partial differentiation of f of x with respect to x. When we differentiate the f of x with respect to x, we get 6x plus 0 minus 30, that is 6x minus 30. And with the, when we differentiate fx with respect to y, then we get 6y. When we differentiate c is equals to fyy, means differentiations of y with respect to y, then we get 6x minus 30. Okay, this is a ABC, and we need to find AC minus B square, that become, what is here? We need to find AC, means that is a 6x minus 30, and C is 6x minus 30 minus B square is 6y whole square. Okay, we need to find this after finding ABC. Okay, next, after getting these four stationary points, that is 6 comma 0, 6 comma 0, 4 comma 0, 5 comma 1 and 5 comma minus 1, we need to draw a table. Let's draw a table. Okay, that is apply 6 comma 0, 4 comma 0, 5 comma 1 and 5 comma minus 1 are the 4 points. We are having a is equals to 6x minus 30 and b is equals to 6y, c is equals to 6x minus 30 and ac minus b square we need to find. Okay, when we apply x in the place, we apply 6x as 6 and y as 0, we get 6 are 36. Yo, 6 are 36. 36 minus 6 is, we get 6. 6 are 36 is, we get 6, which is greater than 0. And in the place of y, when we apply 0, it's become 0. In the place of x, when we apply 6, 6 is 36. 36 minus 30, we get 6. Then AC, A is 6, B is 6, 6 are 36, minus 0, we get 36. 36 is greater than 0. When A is greater than 0 and AC minus B square is greater than 0, then both this is called as minimum point. Okay, this is minimum point. Then apply x is equals to 4 and y is equals to 0. 6 4s are 24. 24 minus 30 is minus 6, which is less than 0. And when we apply y is equals to 0, this becomes 0. Then when we apply x is equals to 0, again we get minus 6 6 are 24. 24 we get minus 6. Then 6 6 are 36. AC means A means minus 6, C is minus 6, minus 6 into minus 6 plus 36 minus 0, we get 36, which is greater than 0. Okay, here A is less than 0 and AC minus B square is greater than 0, hence it's considered as maximum point. Apply x is equals to 5 and y is equals to 1. When x is equals to 5, it's become 0. So when we apply 5 6 sorry, x is equals to 5 and y is equals to 1, c become 30 minus 30 is become 0. Then AC minus 0 means 0. 0 is, in this we get 0. We are also get 0 minus 6, that we get minus 6. This is considered as saddle point because AC minus BC is less than 0, hence this is called as the saddle point. Next, consider x is equals to 5 and y is equals to minus 1. X is equals to 5 means it become 30. 30 minus 30 is 0. When we apply 6 into minus 1, we get minus 6 and this also becomes 0. We know that here we get minus 36 because A is 0, this is also 0. 6 square we get minus 36 that's become less than 0. This is also called as in the saddle point. We get one minimum point and another one is the maximum point, one minimum and one maximum point. Then the value minimum value is when we apply this 6 comma 0 and 4 comma 0 in the given equations, we get the minimum and the maximum point. That is maximum value. Find the maximum value of f of x comma y is equals to, that is 6 comma 0, no, 6 comma 0, x is 6 cube, then it will be 6 cube 3, x value is 6 and y value is 0, minus 15 6 square minus 15 into 0 plus 72 into 6, we get 112. When we solve this, we get 112. Minimum value of f of x is when we apply 4 comma 0 is a minimum point, sorry, 6 comma 0 it's a minimum point, we get 108 will be the minimum point. Okay, so as we apply 5x in the place of x, when we apply the 5, and in the place of 5 when we apply the 1, we get 0 6 0 and minus 36. It's not, it is minus 36 is called minus 36. We get this becomes saddle point. Here also it is become saddle points. When we apply 6 comma 0 and 4 comma 0 in the given questions, then we get the maximum and minimum value. This completions of second problem.